Line plots. Line plots are a type of graph, very similar to a bar graph or a pictograph, and I have some questions that help kind of guide us and introduce us to them. So my first question is, what do the X's mean? The X's actually represent the numbers in the data set. To help me be able to list these numbers, I'm first going to go up to my graph and label each of the pieces. So it goes from 5 to 6. I see it split into 1, 2, 3, 4 sections, and I know that each section will be a fourth. So we got 5 and 2 fourths, 5 and 3 fourths, then we go 6, 6 and a fourth, 6 and 2 fourths, 6 and 3 fourths. Now I can come down and start to list them. So when there's 2 X's above a 5, that means I have 2 5s. There's 3 X's above 5 and a fourth, which means I have 3 5 and 1 fourths. I have 2 5 and 2 fourths, or 5 and a half. Either one works fine for this. I have a 6 and a fourth, and 3 6 and 3 fourths. Whoops. Okay, very nice. So I have, again, each X from our line plot represents a number in that data set as I listed below. Now our next question is, what is the difference between the largest and the smallest number? Okay, so difference gives us a clue that we are going to be subtracting. Okay, so I can put my subtraction sign in there. Now my largest number, I look over, it goes from 5 to 7. So I look where I won't use 7 because I don't have any numbers that made it to 7. I can use my list down here and see that, hey, 6 and 3 fourths was the largest. Or I can look up in my line plot and you can see right here that I had an X and a 6 and 3 fourths. So that's how I know that's my largest. So let's write that. Minus my smallest number here, we have a 5. I can use how I listed them, or that I have my X's above the 5. So now I have my subtraction problem, 6 and 3 fourths minus the 5. The 5 is my smallest number. Now this worked out to be a pretty friendly problem here, so I do 6 minus 5 is 1, 3 fourths minus nothing is 3 fourths. Another good question, or another question that you're typically asked when looking at line plots would be, what is the total of the line plot? Now total usually means to add, so on this one I avoid it because I went a little overboard on my X's, but a question that you would expect to see, and we may see later, you would need to add up each of these values and get a pretty large number. So you would have to add 5, 5, 5 and a quarter, and so on and so forth, and you'd get a rather large answer. Now let's see what we have next. Next up, again, we have some line plots. Now here's another line plot here. You can see it starts at 0. I actually have an X at 0, and then it comes across, there's really nothing. It's split into 1, 2, 3, 4, 5, 6, 7, 8 pieces, so I know it's cut into eighths. So up here I'm just going to label, this would be 1/8, 2/8, 3/8, 5/8, 6/8, and 7/8. Now it's important to note that it's not just 1/8, it's 1 and that, but for the sake of room and not being able to write small enough, I just listed which each of the eighths would be. Okay, so now let's look at this question. Here's another interesting question. It says, what is the sum of the fractions larger than 1/2? So now I have to find 1/2, which ironically is the one that I didn't mark, which is right here. There's 1/2. So all of the fractions larger than 1/2 would be to the right. So what I'm going to do is I'm going to list the fractions that I'll be using. And the first one is 1 5/8 plus, and as you can see, I went ahead and finished the addition problem here. I had 1 5/8. I had 1 6/8, and then I had 1 2 3 4 1 7/8. Now if I'm going to add these up, what I would probably do is I'm going to add up all the whole numbers first, 1 2 3 4 5 6. Then I'm going to go ahead and add up the numerators, and I get 6 and 39/8. Now I don't like 39/8, and I got that by doing 7 plus 7 plus 7 plus 7. Or 4 times 7 is 28, and then I added 11 to it. So I'm going to simplify my 39/8, and that's division. And I know that 8 goes into 39 4 times, with 7 left over. My remainder will be my numerator. My bottom number will stay the same. So actually it's going to be 6 plus 4 7/8 equals our grand total of 10 7/8. And for the second question I have here, I'd like you to try now. So what is the sum of the fractions smaller than 1 1/2? And that will be these that I boxed in red. So I'd like you to follow my same steps, list them out, add them up, simplify if necessary, and then just go ahead and show me your answer as a fraction or a mixed number, a whole number, whatever your answer would be. Let's see here. And our last one, let's take a look at how we would create our own line plot. So this is the opposite. I've been giving you the line plots already created. So now we are going to take our list of numbers here, and you can read through, you can see it looks like we have as small as 8 and possibly as large as 10 1/2. So what I'm going to do here is, first it looks like I'm going to need some halves. So I'm going to go ahead and put in my little half marks on all of these. I can even label them. This is 8 1/2. This would be 9 1/2. And this would be 10 1/2. Now it's very important that we don't miss any. So it's I like to then have a little strategy. I'm going to go straight across that first row. So I have an 8. So I put an X at the 8. Next I have 9 1/2. So I put an X at 9 1/2. Then I have 10. Back to 8. So I stack a second one. 8 1/2. 8. 8 1/2. 10. I'm done the first row, double check. 1, 2, 3, 4, 5, 6, 7, 8 going across, and I have 8 X's. Now I'm going to do the bottom row. Oh, 9, 9, 9. 1, 2, 3 9s. 9 1/2. We have a 10. We have another 9 1/2. We have another 8 1/2. And we finish it off with a 10 1/2. So that is all it takes to create our own line plot. You just simply have your graph. You might need to add some intermediate points or some middle points to help you out. And then for each number, you represent it with an X. And again, that's how we create line plots, and that's how we work with line plots. So I hope this helped.